Yeah, thanks for the pointer to the Spacey Models book.
Well, it's the wrong frickin' version, except I did see that like the classification chapter explicitly says it is compliant with 3.0.
Oh, okay.
However, the real question is the custom training, right? Because that's like probably a pretty valuable piece. So I don't know.
If he's using 2.3 as Yuri says, then then Spacey 3 actually changed the way to do custom training.
Yeah.
Right now
yeah,
it's
no,
all yeah. So
I mean, it's I wouldn't even have published that book. That's desperation.
Exactly. Right. Yeah.
That was a good catch from Yuri.
Yeah.
I couldn't even imagine that a brand new. Hey Yuri, looks like you joined again. Can you hear us? Hello.
Both of them are turned off.
Yeah, you need to unmute yourself, Yuri.
Right.
Okay.
There you go. Yay.
Let me turn off the other sound.
Yeah. Yuri S is actually interfering with Yuri.
Yeah. Yeah, that's definitely disappointing. I mean, because that's like the key thing that would be nice to have guidance on, and that is much better. And you just would not want to do that the old way.
Exactly. Right.
And there's other things too, I think, that are important that have been added as well. So. You there, Yuri? Yeah.
Yeah.
Oh, okay. Should we get started?
Sure.
Okay. All right. Well, what you got, Sujit? Anything interesting going on?
Well, I'm doing this community event, Hugging Face community event for Jax and Flex. So, basically trying to learn Jax, still trying to learn. So I've been doing on the project, I've been doing kind of the ancillary tasks. So, I looked at an external data set, maybe, so that we thought that maybe we could use it as a, once we fine tune the model, we could use it to evaluate our model against it. But this one is satellite pictures, and the thing that we are training it on is aerial pictures. So slight difference, right? It's closer down and you can actually see things much easier. The satellite pictures are like really from the satellite. So, the resolution is very, very, you see mountains and valleys and rivers, but not really like, buildings and stuff. So, so also it didn't quite work the way I wanted it to. I tried raster IO. So it's in TIFF format. So Yuri might know this because you guys might probably use it. So TIFF format, they gave us RGB and they gave us a 16-band one. And I've been able.
Can you say it again?
TIFF. Yeah. So I got images in TIFF format, TIFF, and they have provided us two versions. One is a 3-band RGB, and one is 16-band. So from which I extracted, I think, from the M band, which is the last 16, or the last 8, I pulled out, I think, 1, 2, and 3, or 2, 3, and 4, depending. I think it's 1, 2, and 3 as RGB, right? So regardless, both of them, if I combine the RGBs and try to, and normalize it down to 255, and then I try to view it with IamShow, it gives me like weird colors, right? But if I take one channel and then I see it using IamShow, now this is it's no longer 3 channels deep, it's just 1 channel deep. I'm able to see much better, I can see valleys and trees and whatnot, right?
But in one color.
Only in one channel, yes. Oh, well, the color is kind of weird. I mean, I can force it to go gray, but if I show just one channel, it comes out in a nice shade of green, which looks like the Earth. But if I now put 3 channels, it goes gray for some reason. Oh no, sorry. If I repeat the one channel 3 times, it goes gray, right? So again, not sure, but this is kind of ancillary. We kind of gave up on that. But I thought this was interesting. I mean, in case you know something, I might be able to learn something there. right? So yeah.
If you have a sample, I can look at it. You said you have like more than initially you have more than 3 channels, right? You have like it's
16.
satellite data, so
Yes.
16. Okay. Is it Landsat or
it's the DSTL.
Sentinel?
I think it's DSTL, defense something or other.
Okay.
DSTL image feature detection. Here, let me post this. It's a Kaggle competition. That's where I got it from.
Okay. Oh, but that's a supplementary data. That's not your main.
Yeah.
Okay.
Yeah, and we have basically given up on it. I spent time on it, so and I wasn't able to fully understand how to figure it out. Or I haven't been able to figure it out, which is why I asked the question. The other thing we are doing, I did yesterday, was look at a bunch of PyTorch transforms and selected a few. Again, nothing earth-shaking. I mean, it just took a, see the transforms and plug it into the, the pipeline for image enhancement augmentation. Gautam is doing on the text augmentation, trying to do back translations to get more text. Yeah, and Arto is basically doing the real work. I mean, looking at the script and trying to convert it into a JAX, a JAX-enabled script, basically, right? So JAX is a little different from PyTorch because it's fully functional, and you have to make changes because optimizer in PyTorch or TensorFlow, they are basically the content state, right? So you have to change the way the optimizer is called in JAX. You also have to change you have to define your own loss function outside. You cannot just say binary cross entropy because that contains state too. You also have to, even your model, when you're passing the parameters, so the parameters in your model constitute state, right? So you can't have that, you have to hold the state outside. But again, I understand why, but you have to do these changes. So Arto is basically doing that. And yeah, so once we are done with that, we will start the fine tuning. Hopefully the fine tuning won't take too long because we have the TPU only till Wednesday next week. So yeah.
Yeah, I'll take a look at that data. So one thing, if you wanted to use other scale data, so I have not worked on this myself, but like my colleagues worked on it on my previous job. So with with satellite data, especially when you want to do recognition, you have this thing called, like, basically you have like a zoom level, right?
Right.
So things like look very drastically differently if you have like a different zoom level. So what worked for them in their network is they basically added zoom level as a feature, like somewhere high in the network.
I see. Okay. Okay.
So so that kind of helps you. That helps you scale the network.
Okay.
So you may train it on one type of, like, so I can try to find reference to that. There was they were running like a big classification competition on satellite data, and I think they did like a baseline solution.
Okay.
For that, yeah.
Yeah. Here is the notebook I had. I don't know if it's publicly accessible. Maybe it is. But if it's not, I can share and show you.
Yeah.
What
Yeah. No, I can see it.
Okay. All right.
Yeah, I thank you for the links. I started looking at like different projects, but I like this week is just a little bit crazy. I didn't have time. I saw that the sentence transformer people are doing some work, and actually they, like, I only seen whatever Niels is putting on Twitter. I don't know if I can, like, so I think I tried accessing the Discord, but instead I got pointed to Hugging Face forum.
I see. Okay.
So I don't know if discussion is happening on Discord or
discussion is happening almost solely on Discourse, and also in the Slack channel. almost nothing is happening on the discussion forum.
By the way, so I'm a member of that Slack, but I only see one channel.
That's the one. Everybody is talking on that one.
Okay.
Yeah, it's very confusing, but usually project-specific stuff is happening on discourse, and with Slack, there's like mostly public announcements, and if you have to ask a question from other teams, you have a question which other people can maybe help, so you ask, and that's the communication strategy basically. Intergroup communication is happening on Slack. Within group is happening on Discord.
Yeah, but I finally listened a couple of times to the lecture that was to the presentation before on sentence transformers before the beginning of this sprint, and it's really interesting problems. Like basically, he kind of gave a bunch of assumptions. He said like, well, this worked well, and we should verify that. So I'm kind of interested in seeing like what they're doing. I'm probably not gonna like jump into Jax but I'm interested in so if I can try to join this course, I'll try to do that.
Yeah, I think if you get if you get the Slack invite, then from there I think you should be able to join this course. Oh no, wait. You have to join some project and they will invite you for the discourse. Sorry. Okay. The Discord. Okay.
Okay.
Yeah.
All right. Thanks.
Yeah, I've also gone through. Yesterday, I went through my. So because I'm doing this, I'm supposed to write up a little white paper internally, on Jax and Flex. So I went back and watched some of the videos again, and the second time around, you actually get a lot of stuff that you didn't miss the first time. So that was cool.
The benefits of having to explain to someone else.
Yeah, exactly. Yeah,
for sure. I had something kind of related. Well, first of all, I had a question. So when you talk about functional programming, fundamentally, you mean, your variables just going from one to the next. You know what I mean? Like your data, like you augment the data and it becomes a new variable. You augment it, it becomes a new variable. Okay.
Yeah, no state, basically.
No state. It's not maintaining a state. Got
it.
So the interesting, I heard a podcast from the founder of a company called Neural Magic. You ever heard of that?
No.
Well, their tagline is, AI without hardware. And basically they think that we've gone down the wrong path, although it's a natural path at the beginning of a technology where you have specialized hardware to accelerate your computation or your task. And that's why we've gone to GPUs and TPUs. And he says, well, where it'll eventually go is it'll go from hardware to algorithms. And he explained how their company uses algorithms so you can do everything you would do on a GPU or TPU on CPUs directly. And they're not special CPUs. And he explained how you could take your model. They have a product where you take your model and you can convert it to run on CPU. And I don't remember all of it, but part of it is they do some of that pruning kind of stuff, but they actually train the pruning. So you run it like you could it'll prune it and your model and test its precision recall or whatever your metrics are. And you could do that over and over again because, it's a little random. But then they have other methods. And so but it's not just about pruning and suppression. It also had to do something with breaking the neural network down into columns or sections. So there was some pretty unique stuff going on there. But I thought that's interesting in terms of a big industry point of view. And I think he's probably right. Not that necessarily GPUs or TPUs will go away, but that things will move towards algorithmic. You'll be able to do a lot more on CPU than you can now.
There's usually a trade-off, right? I mean, I was kind of, as you were talking, I was thinking, where is the catch? right? And the catch is where, he's pruning the thing and he's making the thing simpler, right? Not necessarily a bad thing, but, that's where you would get rid of the computations, basically, right?
I think it's more than that. And also, I think the amount of trade-off is like smaller than you would expect. So anyway, it's just sort of, he's a big he's evangelizing the big picture future of the industry and the tool that they built and things like that. So, but anyway, you can look closer at it if you find it interesting. But
neural magic, okay. All right,
yeah,
interesting. Yeah. This is interesting. Yeah,
it wasn't just it wasn't just technologies you've heard before, like quantizing, right, applied in a product. It was actually serious algorithmic work, right, that they were doing, and techniques that were quite unique as well. So anyway, yeah. Other than that, I mean, I can give a quick update on what I've been doing. So I'm just really getting back from vacation and getting back into things, and still trying to learn. While at work, the main thing is still working with Vertex, and I'm trying to take the model I built for page types for web pages to which seemed to be fairly effective, even though there were some pretty big data input issues I caught, like the wrong language, and I included another category, which I shouldn't have. But now what I'm doing is I just spent like a day trying to use the bulk inference on Vertex, Google's Vertex. So basically, you don't need an endpoint for it. It just runs it straight on the model, and you just create a file, it's important because the endpoint's expensive to run. Or from my point of view, right now as a proof of concept, it's kind of expensive to run. So instead, you could do bulk directly on the model, and you just do it. You can do it through the GUI, and you just have to have a file that's formatted in the right way, and it points to your files in GCP. So it just took me a bunch of glitchy stuff to figure that out. And I actually finally ran it yesterday, and today I'm going to try to analyze the results. And the main point of all of that is to take all of the stuff that our regex, all of the pages that our regex couldn't find any page type for, and see if this model can now find some page types. So we'll increase our coverage. If this all works, it'll be a nice, clean example of using bootstrapping from regex to, ML using some form of auto ML, hosted auto ML or managed auto ML. So anyway, that's where I am with the Vertex stuff. Outside of that, I've just been reading about neural network architectures, trying to get the big picture framework, and doing a little bit of. I've never had a formal intro to CNNs actually, so I'm doing a chapter in the Inside Deep Learning book. It's a Manning book because that's PyTorch. Okay. I really like PyTorch.
Okay.
Yeah, from what we did in the one class, I stayed in for a couple of the first classes. And I really like that. And yeah, I think that was the DL PyTorch channel or class, right? Which you suggested I did do. Okay, so that's really it for me. I just hope continuing on those paths, and then eventually get to back to multi-label classification, and maybe also zero shot or one shot or whatever classification at some point. So that's all I got. Suji, were you finished with what you have? Have you been reading anything else?
So I've also been doing the graph class, right? So I'm doing the homework, the second homework. In the process, I found, I ended up not using it, but the second homework contains slightly larger graphs. So I was afraid that Network X won't handle it, in the suitable amount of time. So I started looking at CuGraph on NVIDIA Rapids. So I haven't actually deployed it. I might, but now I know how to.
What's that called?
CU graph. So it's CUDA graph, CUDA ML. So they have a set of libraries built to run on GPUs. This is NVIDIA, called Rapids, right?
No. Yeah. I'm familiar with Rapids.
Okay.
Just not with the. Yeah. They're great. They have the data frame also, framework, and I didn't know they had the graph stuff.
Nice. Yeah, it's a NetworkX lookalike. So I was planning to use that, but so I started looking around. In the process, I found a Coursera course on graph analytics, which seems quite interesting. So it's in the GraphML CES224W channel, or I can paste it if you want. Okay, let me do that. Copy link, and then I'll just dump it here. Actually, I'll put it in the, so it'll show up in, I'll put it in the channel, NLP Embeddings. Right? So it'll show up there with the thing. Yeah. If you go to the original message, then you'll find the link to the Coursera class. I thought that was good in case you're into graphs, because third week it covers third or fourth week it covers Neo4j, and the fifth week it covers Spark Giraffe. So Spark and Giraffe basically. So nice tools to learn. And it's not the tools, what they do is not really covered by typical pygeometric or neural network kind of things. They focus more on the aggregate and broadcast kind of loop, right? So you not aggregate, actually broadcast and aggregate, right? Each node broadcasts its properties to its neighbors, and each node then takes all the incoming properties and does some aggregation, and the cycle repeats till everything kind of stabilizes, like typical PageRank kind of thing.
And that I don't know. So that's not GraphML. That's not using ML techniques.
That's not
GNN or whatever.
It's not, well, GNN kind of borrows the techniques, but this gives you complete freedom, right? I mean, this basically allows you to describe your pipeline in code, whereas with GNNs you're saying that okay, you do this, but then there is a the ReLU and the linear thing in front of it.
Well, let me ask you something. So the GraphML stuff, it seems to me, I researched a little more as well a while ago. I mean, adding on from our last call, we talked about that you basically have a feature matrix. Now you can have more than one feature matrix for a node, but in general, you have a feature matrix.
Yes.
And so everything's in matrices, whether it's tabular or NLP or whatever, you know what I mean? Whether it's a vocabulary or whether it's tabular, you do the same thing. It's just a feature space. Is that also this stuff, or is this different than that? Because it sounds like pre-ML, kind of pre-modern ML.
Pre-neural networks, right? So if you think, okay, ML, okay, maybe kind of a branch of from if you think of ML being, basically linear algebra, right? So this is kind of a branch off of that, right? It branched off around the same time, and this became like graph-based kind of things. It still uses linear algebra in a lot of cases under the covers, but not in this particular case with the broadcast aggregate kind of deal. That kind of your mental model is a graph, right? Because you're saying, okay, here is a node and it's connected to other nodes, and I broadcast my properties out, and then on the other side, it aggregates all the properties, and so the mental model is that of a interconnected mesh. Whereas you could think of the same thing as maybe with doing adjacency matrix, and then creating the Laplacian out of it, and then multiplying the Laplacian over and over again, right? Or decomposing it, right? So and then it becomes kind of the same thing, but that's more of a a linear algebra based kind of idea.
So what's the data model look like though? Is it like the where you just have a nodes with the feature, each has a set of features? So it's basically a matrix. It's all matrix based.
Yes.
Okay. And can you point me? I don't see that in Slack. Can you point me to this
hang on.
class or a source actually that talks about this type of graph analytics?
Oh, I can send you the course link. Hang on. I'll paste it here. It's actually embedded in there. The pictures don't come through on the link version.
Oh, there it is. Coursera. Okay. That should give me a good foothold into
PubGeo. Okay. Thanks, Yuri. I will look at this PubGeo data sets. I just missed. I didn't see it before.
Yeah, I specifically saw several presentations and kind of looked at functional map of the world, which is like from a few years ago. But that's when they were like setting up classification. That's where I think they used the zoom level.
Okay.
It looks like they've been running those competitions. There's, by the way, I should put, so they mentioned SpaceNet. There are a bunch of competitions run by SpaceNet, which has a lot of data. I haven't thought about it. So SpaceNet just sort of like the company that was running it, I think, stopped doing it and it kind of stopped existing. But I think all of them went to Amazon because they were in DC. But they have in SpaceNet has a lot more data. But
yeah, it does look that way. I'm looking at SpaceNet AI datasets, and they said like they have all moved to AWS public datasets. 67,000 square kilometers of very high resolution imagery, and you can see buildings here. This is nice. They have some pictures. Let me post it so that yeah. But it looks like, so this I have noticed, right? Even with the DSTL images, they're very dark, right? Is this something like, if I do like an RGB, it's super dark, right? So then I have to, even if I push it, to, take the bottom as, instead of, taking the bottom and the top, I just cut it down to 255. It becomes nicer, but the colors get unnatural. Yeah, but I guess it's what it is. So.
Yeah, a lot of the other competitions, it's all like RGB, so it should be natural. Later they started, added like SAR.
Okay.
But yeah, I'll take a look. I'm interested, and we usually like very few people actually look at data with somebody's processed. We get it in like time series.
All right. How about yourself, Yuri? You've been reading anything or anything random or interesting at work to share?
No, not much. So I called into Graph to the GraphML class, but like I don't think I counted classes correctly, so I wasn't on the page because you guys are going pretty quickly.
Yeah.
So yeah. So I listened as fast as I could, but I didn't catch up.
Yeah, it's hard, but in a sense, you get over it quickly. So in that sense, it's good, I guess. You can always come back to things you don't fully understand. So yeah. That is the opposite of the unsupervised one, where we are going like super slow.
So I don't know, I may come back. Actually, I have a question for Sujit. So do you work with LexisNexis at all, or is that like a different part of the company?
It's a totally different company.
Okay.
Yeah, the only time we meet is once a year in the CERT Summit.
Do you know they publish like is there like a presentation on how like ontology is used in LexisNexis, or is that like internal? It's never published.
I don't know honestly, but the ontology they have is actually well, actually it's more in line with the ontologies you use, right? So your agricultural ontology, it's not as detailed as the one I'm used to, the clinical one, but it's more like topics, right? Important topics. So, but that's about all I know. I know this because we were once, I was involved in a ambulance chasing application, right? Where you have, basically lawyers want to know what kind of, issues you have when you are sick, right? A person is sick. And then based on that, what are the precedents and so on, right? So yeah, so that's why I know their level at which they are, they classify their stuff. They actually call it a classifier, not a ontology.
Yeah. So yeah, there's very specific reason for the question. We have a program manager who came from LexisNexis.
Okay.
So when she talks about ontology, I want to know like what she means.
Well, she might mean something completely different if she's talking about the Lexis side. Well, kind of similar, but the Lexis and Nexus sides are very different, right, Suji?
Yeah. Okay. You actually were employed by them. Okay. You would actually probably know better. Yeah. Okay.
No, I was employed by Reed Business. So like you, Reed Elsevier.
Oh, I see. Okay.
Like, so I was part of Reed Elsevier like you, but we were, I mean, I've been to Ohio once and met a bunch of those dudes, but I don't know anymore. I know the Nexus side is the, which is the legal? The Lexis is the legal side, right?
I think both of them are, no? LexisNexis legal, and so now they have a legal and professional, and they have a risk solutions.
No. They used to have, I mean, come on, Lexis used to do research, right? It was not, I thought they had non-legal research side. I didn't think it was all legal.
It's all legal now, at least.
Oh, okay.
Yeah, they have an insurance business as well, risk solutions. They're a recent acquisition, and they are kind of, they don't feel like they're part of LexisNexis because they feel superior. So there is that thing, the internal thing going around there. They don't like their, being called LexisNexis risk. They would prefer to be called risk.
So what that person might, so do you know their background, Yuri? Like, are they highly technical, or are they like just like managerial, or what level are they? Librarian
I think like
level?
legal/managerial, but
okay.
But so like topic classification sounded right. That's how.
So traditionally, I'm sure Suji, you're familiar with this. You know what a search thesaurus is. Like when I went to library school, I mean, there were actually still print versions of it available, but it's a thesaurus, right? I don't know, Yuri, if you've heard of a search thesaurus, but it's it's where I'm sure you've seen it, but rather than a taxonomy or rather than subject headings, it's actually where you have broader or narrower relationships and related relationships, and it's pretty formal and large. And they used to publish them in books. And when you were doing legal research and you sat down at your terminal, you would use that to build your language for searching. So they're also called search thesauri, right? And so it could possibly be this person is explicitly talking about their traditional search thesauri, which they still use. I'm sure researchers probably still use, maybe.
Would be, yeah.
Suji, does that make sense, Suji?
Yeah, I mean, I haven't actually. So what you described, I think of as a taxonomy, like only a hierarchy, no graphs, right? And I think of ontology as like a taxonomy plus, sibling connections, right? So I think of it as a taxonomy, but I've actually never seen one. This is, but yeah.
Yeah, no, it definitely was different. They were considered different taxonomy, at least in the more formal world I lived in terms of taxonomies.
Right.
Taxonomies is hierarchical. It can have related, but search thesaurus are much broader and shallower and more free form.
Okay.
And they have these NT, BT, RT related, and they're used to build up a search query when you're using those paid search systems like LexisNexis. And if this person is traditional, they explicitly are thinking about that in their mind. I'm trying to find, maybe they don't exist anymore. I'm sure they do, but, or maybe it's still at the center of using LexisNexis. But anyway.
Yeah, way back in Healthline, when I joined them, they had something called a BNR component, and they would surface it with every search. So I think it is kind of similar. BNR is broader, broader, narrower related, right? So anytime we found something, we would basically show them what else is there in the taxonomy around that, right? And so that could give them search ideas. So I think the purpose is very, very similar. This, the search thesaurus, except now it's online.
Yeah. All right.
Very cool. Yeah.
All right. Well, you have anything else, Yuri?
No.
All right. Well, that's all I got. Nothing too exciting there for me. So, I mean, unless you guys have anything else you want to talk about, we could just call it a call.
Yeah, I don't have anything else.
Okay. No big deal. We'll talk next week.
Okay. Cool.
Okay. Enjoy the week, guys. Bye.
All right.
Thank you.
Bye.